Now let's take a problem of complementing an NFA. We have already seen the complementation in case of DFA, and in DFA what did we see? If we complement a DFA, the language accepted by the DFA is getting complemented, but in case of NFA it is not true. So let us take one example and I'll show you how the complementation of NFA is going to affect the language accepted by the NFA. Fine. So let us say I want to construct an NFA which accepts set of all strings over a comma b, where each string starts with a, NA. Fine. So NFA is going to just look like this: a comma b. That's it, right? Let us say we have two states, a, b, and now A is the initial state, B is the final state. If it is going to start with A, I am going to accept. I am not going to talk about what happens to A if it sees a B. That will go to a dead configuration, and I am not going to talk about it. Okay? Why? Because it is NFA. Let us represent this NFA as M. Now if I complement the NFA, see, complementing a language is different and complementing the NFA is different. If I complement the NFA, what is complementing of NFA? Make the make the non-final states as final states. What are the non-final states here? Only A. Make it final state and make the final states non-final. This is the final state, make it as non-final and leave all the other edges as it is. This is the NFA. Now, what is the language accepted by M, the original NFA? The language accepted by original NFA is set of all strings which are going to start with A, B, so on. And what is the language accepted by M complement? Let us say L1 is the language accepted by the initial NFA M, and L2 is the language accepted by the complemented NFA M complement. Then what is it? It is simply only epsilon. If I see A, it is going to other state and it is not going to accept it, and B, there is no chance that it is going to accept it. So just look at these two. You can find out that L1 is not equal to L1 complement is not equal to L2. What is L1 complement? L1 complement should contain epsilon as well as strings starting with B, but then it is only containing epsilon. Where are the strings starting with B? See, if I take the entire sigma star to be this, one will contain starts with A, so for which there is the machine, whatever it is, the language L1, and the L1 complement is, it will even contain epsilon as well as starts with B, but then we got only epsilon, which means if I complement a NFA, the language need not get complemented, which means let us assume that I have an NFA M. If I apply the complementation and if I get NFA M complement, if the original language is accepting language L1, then the complemented language, this one, the language accepted by the complemented NFA need not necessarily be the complement of this, and sometimes it may be complement, right? So you have to get one point here: complementing an NFA is different and complementing the language is different. So I'll try to frame two questions here, try to get the difference. See, first point is, when we complement a DFA, definitely the language accepted by the DFA is going to be complemented, but when I complement a NFA, the language accepted by the NFA need not get complemented. It may or may not get. Okay, so I'll try to give you two statements, maybe try to understand them. One is, the question may be, what is the language accepted by complement of NFA And the other question is, what is the complement of language accepted by NFA? Both are different. See this. First one is, what is the complement of the language accepted? What is the language accepted by complement of NFA? Which means take the NFA and do the complementation of the NFA and then find the answer. And the other one is, what is the complement of the language accepted by the NFA? Which means take the language accepted by the NFA, find out the language and then complement the language. Both are very different. Okay, you have to understand the difference. Why? Since the complementation of NFA need not necessarily complement the language, therefore these two questions are very different. What is the language accepted by complement of NFA and what is the language accepted by, I'll just take an example and explain you. Let us assume that this is the NFA given. This is the NFA given directly and nothing else is given. They didn't give you anything. Okay. Now if the question is, if the question in the gate is, what is the complement of language accepted by this NFA? If this is the question, then you have to find the language accepted by this NFA and then complement the language. What is the language accepted by the NFA? Language accepted by the NFA is set of all strings which are going to start with A, which means A, AA, AB, AAA, so on. Now you have found out the language. After finding the language, find the complement of the language, right? So for this question, answer is the complement of the language accepted by this finite automata is NFA is epsilon as well as string starting with B, BB, BA, BBB, so on. Now if the question is, what is the language accepted by complement of the following NFA? If this is the question, take the NFA and complement it. If I take the NFA and complement it, it is going to look like this. This is the NFA's complement. Now what is the language accepted by complement of it? It is epsilon. Therefore answer is this. For the first question the answer is epsilon as well as all strings starting with B. For the second one the answer is this one. If they had given you a DFA, the answer for both the questions would be same. So from this question you should understand that if I complement a NFA, the language need not necessarily get complicated but then complemented. But then there are cases where if you complement NFA, the language may get complemented. So what is the best example for that? Since every DFA is an NFA, you can take a DFA and say that it is an NFA and then complement the language and you will get the complement of it, right? So these two questions are important.